Hi guys, today we are going to look at this problem called construct quad tree. Uh, the description is very confusing, but let's see the example. So we are given a structure, we're given a class where we have a value is leaf, a top left, a top right, bottom left, bottom right. These are the four pointers which are called the four children of this node, and its value is, uh, it's a boolean, which means it can be 0 or 1, and is leaf is again, if all the other four nodes are null, then this is a leaf. This is true in that case. So we are given a grid, and we are asked to return a node, right? How are we going to do that? So they have told that we have to construct the node using this grid, and this grid itself can be divided into four parts or four children. So this complete grid in itself can be considered as a node where the four children are the four subgrids that we can form of equal lengths, right? So these are the four grids. These are the four grids, and these are the corresponding four nodes or four children. This one is this, bottom left is this, bottom right is this one. And what is the value? So if in the grid or in the node, if all the values are 1 or zeros, in that case this is a leaf node, and the value is going to be whatever value the grid is having. If all ones, then this is going to be 1. If all zeros, then this is going to be 0. If it has both ones and zeros, which we have in this scenario where this is a node and all the, let me clear this up. This is the node, all the values are, not equal. They have ones, they have zeros. So in that case, the value can be either of the value. I mean, it doesn't matter. It can be 0 or 1, both are acceptable. Is leaf is going to be false because this is not the leaf. We can further divide and find that we have a node which is a leaf node and all the values are 1. That's why value will be 1. And the 4, since we are not going, dividing this grid further, that's why all the 4 children are going to be null. So this is the whole thing. Let's see this example. Let's see this example. This is a good example. So here, this grid is not a leaf node because not all the values are equal. So that's why this is 0. Value can be anything, doesn't matter. Is leaf. So this is the top left. Top left is this grid which has all ones. That's why it's a is leaf. I mean it's a leaf, and its value is going to be 1 because all the values are 1. Similarly, bottom or top right. This is the top right. We see that this is not a leaf node, so this is 0, and the value can be anything. It is further divided into four parts. Now we see that all the values are zeros. I mean, it's 0 here, so it's a leaf node. Top right is 0, again, it's a leaf node. Bottom left is 1, it's a leaf node. Bottom right is 1, it's a leaf node. Similarly, bottom left and bottom right. So this is how we are going to do it. I mean, this is what we need to do, and how we are going to do it. Basically, we can recursively keep on dividing this, but then the question is, uh, how are we going to find if this node has all ones or all zeros? Since the constraint, if we look at it, it's very small. That's why we can iterate in every recursive call. But there's a better approach. We can create something called prefix sum, right? And prefix sum for each block. For each block, we can use that prefix grid to find if all the value, if the sum of this grid is equal to 16 or it's equal to 0, right? If it's equal to 16, then all the values are 1. If it's equal to 0, then all the values are 0. If it's none of them, then it's not a leaf node. We are going to divide it further, right? So that's how we are going to do it. So simple explanation. Let's get into the code. So this is a this is the grid. This is the prefix that I have made. The size will be, let me take it outside into M and N, since we are going to have to use this frequently, that's why. So I can use M and N here. This will be N. Initially the values will be 0. I'll first fill up the first, since I'm making a prefix, I'll first fill up the first row and the first column, and then I'll fill up these remaining rows and columns, right? So int I is equal to 0, I less than m, I plus plus, prefix of I and 0, since I'm using, creating prefix for this part, so the column will be 0. Here prefix of I minus 1, or let me do that from first, and I'll initialize the first row, first value to be grid value, grid 0 0. Alright, and now I'll use that and the current grid value. Now this will create my first row. Similarly, I'll create the first column like this. This will be n, the column will be j, the row will be 0. Again, the row will be 0, the column will be j minus 1. Here, the column, the row will be 0, the column will be j. Alright, this will create my second, the first column. The first row, first column is done. I'll now go for the remaining values, that will be from 1 till n, and for j it will be from 1 till n, and prefix of I j is equal to, it's a pretty uh, straightforward creation of prefix, so it's basically prefix of I j minus 1 plus prefix of j, I minus 1 j minus, or let me do the minus at the last, plus grid of ij minus prefix of I minus 1 j minus 1. So I'm writing this formula. It's a very, it's the only way how we create the prefix. So if you don't know, just try to dry run using this formula, and you will get the idea. First, I suggest that do it for a 1D matrix, 1D array, not a 2D matrix straight away. After that, using the same idea, we can do that for 2D array. So this is my matrix. I'll call the construct quadrant function, which will be taking prefix. This will return my node, so I'll return it here. Let me fill the remaining arguments as I go. This will be node, and this will take prefix first as the first argument. I'll pass by reference since I won't be changing this. The next thing is I will need the row and the column. The starting row I can take, I can keep track of the particular grid wherever I am using uh, a start row start column and an end row end column. If we, just for understanding, I'll be doing that start row start column, end row end column for each particular grid. I'll be using these to keep track of it. But if we look at it, we don't even need that. We can just keep track of how many divisions we have done and the first origin and the first starting row starting column. So wherever I am, if I have the number of divisions, like how many times I've divided n by 2 by 2 by 2, right? These are all powers of 2 because it's given in the question as well. So I can do that, but just for the sake of simplicity, I'll be using start row start column and end row end column instead of doing the other way. So this will be start row start column and row and column. Now I'll pass the things. So this will be 0, 0. This will be n minus 1 and n minus 1. These are indices that I'm passing. So m minus 1, n minus 1. And inside that, the base condition will be when I am at the minimum possible division, right? That is, I am at this atomic cell, right? I'm here. So at this point, the start row and the start end row will be same. The start column and end column will also be same. Start row is equal to start column and start. Sorry, this will be end row. Similarly, start column is equal to end column. Here I will return a new node because I am at a point where I can't further divide it, right? And at this point the value is going to be either 1 or 0, right? How am I going to determine it using prefix? I can do that, but instead, for simplicity, let me also pass the grid just for this case. Otherwise I won't be needing the grid further in the code, but just for this space I have to get the grid. Otherwise I can use prefix, but that is going to be a bit of a calculation just for a small value. And anyways, I'm passing the reference, so it's not going to be a huge memory overload or something like that. So node will be so we have few constructors. We can use this one since this is the one that we need, because all the 4 neighbors will be null. So value will be grid start row start column. This will be the grid, and the leaf, it will be a leaf node, so it will be true. Alright, now I need to find the sum. So at this point I have a grid, I have a prefix, I have a start row in the start column, end row, end column. So I can get the sum using these parameters. I can get the sum between these grid values, right? This particular thing represents a grid, and using prefix I can find the sum of that particular grid. How can I do that? So in prefix sum we have a popular formula. Again, it's basically the opposite of this, right? So let me show you. So if this is the point, or suppose let me take this grid. Suppose this is a prefix. It's not a grid, it's a prefix. Let's assume that I want the sum of this grid. How can I do that? So this is the start row, this is the start column. Sorry, this is the end row, end column, start row, start column, and this is the total sum of this whole grid. Since this is a prefix, this is the total sum of this whole grid. Alright, then I can subtract this to remove this. I can subtract this to remove this. But now you see that this part has been removed from this value twice, right? So we have to add it once. So we will add this value once. So basically what I'm saying is, let's see in the code so that you can understand. So I have some things to be added. Let me get the formula first. I'll do the edge case. I'll handle the edge cases later. So the formula will be prefix of end row. This part was end row end column, right? So end row end column. I'll remove prefix of end row and start column minus 1. Why this? Because you see, here, if I remove this value, right, this is what? This is end row and start column minus 1, and this is start row minus 1, end column. Alright, so basically I am subtracting another value, and that is prefix of end row, sorry, start row minus 1 and end column. And I'm adding this value, the one which is prefix of start row minus 1 and end column, sorry, start column. This can be confusing, just keep your head straight and get the formula. After that, handle the edge cases, so that's going to be helpful. So this is what I will be having as the formula. Now I have to handle scenarios where this will be negative, right? Start column can be 0, start row can be 0. So I'll have something called to be added, which will be 0 initially, and to be subtracted, which will be 0 initially. If the start row is less than 0, sorry, is greater than equal to 0, uh, or let me do that. Start row minus 1 is greater than equal to 0. In that case, I can have this. So I can add this value in the to be subtracted part. Alright. This anyways is going to be always valid, but just for the ones where I do minus 1, I have to make sure that it is valid. If the start column is also greater than equal to 0, in that case I'll make sure that I add this in the to be added part. I don't need plus equal to because this is the only value that I need or I don't need, right? So if now start column is greater than equal to 0 as well, I'm not doing this part here since I'm also checking here the same thing, but I may or may not have start row minus 1 greater than equal to, so I don't want to be dependent when this is true. I don't care about this one. So I'm checking it here again, the same thing, but for this value. Finally, I can change this whole thing to be subtracted and this whole thing to be added. Finally, I have the sum. If the sum is equal to 0, then I return with the new node. The value will be 0 and the leaf will be true. If now I have to check for ones, so how I'm going to check for ones. So the number of ones will be nothing but end row minus start row plus 1. These are the number of rows into the number of columns plus 1 is equal to sum. If that is the case, then I'm going to return new node. Here it will be 1 comma 2. Finally, I'm going to divide. I keep on dividing, but for that I'm going to need a mid row and mid column because I'm dividing, right? So this will be nothing but start row plus column row by 2. Or in before I do that, let me call the functions and then I'll call it and I'll declare the variables. So here I'm going to have a node that I'm going to return. Right, so I'm dividing. And here I'm dividing this whole grid into 4 parts. So this will be a node which I'll call n, and this will be, since this is going to be divided, its value can be either 0 or 1. I don't care. So I can use this constructor. So it will be false and false. Alright. So I didn't pass anything in the constructor. I call the construct quadtree for the top left We'll call the construct for tree, and here I'm going to pass the prefix or the grid as well. The grid prefix, the start row, comma start column, comma end not end row, right? So I am dividing it into four parts, right? So this will be nothing but mid row, comma mid column. What is mid row, mid column? Mid row will be nothing but start row plus end row divided by 2. Similarly, mid column, this is nothing but column. This will be mid column, and I'm going to copy this for the three other neighbors. That will be top right. This will be bottom left. This will be bottom right. Here, this will be from this part to this part, isn't it? So this was top left, start row, start column, mid column. This will be start row, mid column plus one, and mid row, end column, isn't it? Just use the diagram and try to find the arguments. That's what I'm doing. For the bottom left will be uh, mid row plus one, column will be start column, and the final column and rows will be uh, end row and mid column. Alright, this will be mid row plus one, mid column plus one, end row, end column, and I return this node. So this is the code. Let's see if this works. I mean, there's an easier way to implement this, but this is what I came up, and it's easier to understand, and it's not that it's optimal as well. Uh, so somewhere it's going outside bounds. Let's see where it is. Start row minus one, that's fine. Start column minus one greater than equal to 0, that's fine. To be subtracted, I'm subtracting that. End row is not ever going invalid. Start row is not being invalid. Uh, this is from start row, start column, mid row, mid column. Is it like prefix on the screen? That's fine, this is correct. This looks good. This is where I think the problem is. It should be M. Right, it's still breaking somewhere. So this is going out of bounds here. This was a silly mistake because I'm not checking. I said that I will check this, but I forgot to put a minus one here, and that's why it's going out of bounds. Guess this should work because I just to find that I've checked everything, so everything else was correct. The time complexity will be, since we are keeping on dividing, the grid into four parts. So we have a factor of log m cross n. Uh, Log m cross n comes from the fact that we are dividing the grid into equal parts again and again. So it's kind of a binary search, like we do it, right? And we get a factor of n cross n. There we get a factor of log n because that's a 1D array for binary search. On top of that, we are creating a grid, so n cross n from that part. If we wouldn't have created the grid, prefix grid, and would have traversed it in each recursive call, then this will be a multiplication instead of a addition, I think, and the space complexity will be O of n cross n. So yeah, thanks guys.